number kind of like goes up.
It goes up. It's like the way that we count, right? We count in order. So consecutive are numbers that come in a row or in order, like 1, 2, 3, 4, 5. -5, -4, -3, -2. Okay. So today we're going to talk about consecutive integers, and we're going to talk about consecutive integers as well as consecutive evens and consecutive odds. Okay. So integers are a subset of the real numbers. They're just positive and negative whole numbers, no decimals. So when you're ever doing a problem of consecutive integers, let's say that you're doing a word problem with consecutive integers, if you ever get a decimal answer, that should be an indicator that something went wrong, a decimal or a fraction, right? Okay, something went wrong. So we're going to talk about just using some guess and check first. So we're working with two consecutive integers. So I'm going to start off with like 4 and 5. And we're just going to see if this works. So we want to take two integers whose sum, what does that mean? Their total. So their sum, 4 plus 5, is, what does is mean? Equal sign, good job, is 11 less than 3 times the smaller integer. 11 less than 3 times the smaller. So what's that going to look like? Which one is the smaller number, Owen?
Within that equation, look like 3x minus 11.
Well, we know what our numbers are. So instead of 3x, we're going to use 3 times 4, because that's our smaller number, minus 11. This is just a try. We're just trying this. We're kind of doing a guess and check. So let's see. 4 plus 5 is 9, and 3 times 4 is 12, minus 11. That means that 9 equals 1. Is that true? No, it's not true. So this one doesn't work. What are 2 more numbers you want to try? 7 and 8? I think that's a good try. Let's try 7 and 8. Let's try the number 7 and 8. So the sum, 7 plus 8, equals 3 times the smaller number, minus 11. Okay. Well, what is 7 plus 8? 15. Okay. And 3 times 7 is 21. Okay. So does 15 equal 10? Does 15 equal 10? No. So we know that 7 and 8 is not going to work. What do you want to try next? Oh, I think we need to go bigger. Like maybe 9 and 10. Okay. Let's try 9 and 10. So their sum, 9 plus 10, is equal to 3 times the smaller number, which would be 3 times 9, minus 11. 19 equals 27 minus 11. So does 19 equal 16? Does that one work? But we're getting closer. Notice here, this had a difference of 8. Like the difference between them was 8. Here, the difference between them was 5. And now our difference is only 3. So we're getting closer. We're getting closer to find it, but this one does not work either. So we could keep doing this forever, but instead, I think it's probably easier to set up an equation. So it says, carefully set up statements that make our expressions two consecutive integers. So if we let x equal the smaller one, right? Because that's what we kept talking about, something times the smaller. And they're consecutive, what is the second integer or the larger one going to be? There are numbers right in a row. So like, what's the difference between 4 and 5, or 7 and 8, or 9 and 10? What are we adding? 1. So our next one, x plus 1, is going to equal the larger integer. Okay. So let's try this. It says the sum of the two integers. I'm just going to write this down. Sum of the integers. So that means that I'm going to take x plus 1 is equal to 3 times the smaller minus 11. So what's that going to look like? What does 3 times the smaller integer look like? Because Owen, you told us last time. You gave us that actually algebraic. What did you say?
I said 3x minus 11.
Perfect. Okay, so now we have an equation that has variables on both sides. So we have to first combine like terms, and then we're going to try to get all of our variables on the left side, all of our constants on the right. So combining like terms, I can group these two things together. X plus x is 2x. So I have 2x plus 1 equals 3x minus 11. So do you want to subtract 2x from both sides, or do you want to subtract 3x from both sides? It doesn't matter as long as we get all the x's on one side and all the constants on the other. Subtract 3x from both sides. Minus 3x. Remember, whatever I do on one side, I have to do on the other. 2 minus 3 is -1. So I have -1x plus 1 equals -11. Now I have to move that constant of 1 over to one side or the other. -1 on both sides. Good job. Yeah, thank you, both sides. I love that. So -1x equals -12. Divide both sides by -1. Good job, Ariana. Divide both sides by -1, and I find out that x equals 12. We were so close to figuring out what our numbers were, right? So our smaller integer is 12. That means that the one that comes right after it, x plus 1, or 12 plus 1 is 13. The one that comes right after it, the 12 plus 1 is 13. So when we use consecutive integers or consecutive even or consecutive odd, it is easier. It is easier to use expressions, algebraic expressions, instead of trying to do that whole plug, guess, and check, plug, guess, and check. Especially, what if you had to do like 3 odd consecutive integers and you just kept trying 3 different numbers over and over again? That could be really tedious. Okay. Yes.
I have a question.
Yes, ma'am.
So like, okay, I might be stupid, but
No.
whenever you do them, like, do you always put like the minus 11 at the end?
Well, so read the statement. So the statement, I know it doesn't say it in B, but what we were trying to solve was for this statement up here. We have 2 consecutive integers whose sum, and Tyler told us the sum is that we're going to add them together, is 11 less than. So that's why we subtracted 11. Does that make sense? Good deal. Anyone need more time on this one? Okay, go ahead and go to the next page. So let's try some more problems. And this time we're going to just we're going to just focus on working with expressions. We're going to focus on working with expressions. Okay. So we have 3 consecutive odd integers. So I'm going to write some odd integers up at the top, like 3, 5, and 7. That's a set of 3 consecutive integers. Guys, pick up your pencils. Kylie, come on, please, and thank you. Another set of odd consecutive integers. What about -7, -5, and -3? If this first integer is x, how do I get to the next one? I'm adding 2. If this first integer is x, how do I get to the third one? X plus what gives me 3 plus what gives me 7? 4. So even though we're talking about odd integers, they're two numbers apart, right? 3 plus 2 is 5. 5 plus 2 is?
Teachers, may I have your attention, please? We have a late bus that's just arrived.
They're gonna be late for the next 3 days.
Students to go to class. Bus 253 has arrived, so please allow those students to go to the class. Thank you.
Okay. So we have 3 consecutive odd integers. So we have to define our variables, which is kind of what we wrote at the top. So here's how I always define my variables. So I'm going to say that my first integer is x. So my second integer is x plus 2. And my third integer is x plus 4. So we have defined our 3 integers, and now we have to read to see how we're going to set up our algebraic expression or our algebraic equation. So it says when I add the larger 2, so which 2 integers are the larger 2? The second and the third. So I'm just going to write add the larger 2. So Isaac said that's the second plus the third. I'm going to do some thinking first. The result is, what does that mean? That means equals, right? The result is 9 less than 3 times the smallest. 9 less than 3 times the smallest. So 3 times the small minus 9. So now we're going to kind of plug that idea in using our expression. So what expression represents the second integer? What algebraic expression, Avery, represents the second integer? What algebraic expression represents the second integer? Yep. So we're going to replace the second integer with the expression x plus 2. Plus, Victoria, what algebraic expression represents the third integer? Plus x plus 4. So that's the sum of the larger 2 is 3 times the smaller integer. What is the smaller integer? Just the smallest one is what? Just x, right? The smaller one is just x minus 9. So we need to do some combining of like terms again. Combining of like terms. So what's it going to look like on the left side? What are some of the things I can combine? Both x's and the, God bless you, and the 2 and the 4. So x plus x is 2x. And 2 plus 4 is? Okay. Equals 3 times x is just 3x minus 9. All right, Lissandro. We need to get all the x's on one side and all the constants on the other. So what do you want to move? Do you want to subtract 2x from both sides or subtract 3x? Sure. Let's subtract 3x from both sides. So when I subtract 3x from both sides, let's see, 2 minus 3 is -1. So I have -1x plus 6 equals -9. Ken, what do you want to do next? We have to move that 6 out of the way.
Plus 1.
I have to get rid of that 6. Minus it. Yes, sir. We're going to subtract it from both sides. Thank you, both sides. So we're going to subtract that 6 from both sides. And when I do that, I have -1x equals -15. Last step. Yeah, good job. Divide both sides by -1. So x equals a positive 15. So that means that our integers, the integers that we're talking about, the 3 consecutive odd integers are, well, x is 15. So x plus 2, or 15 plus 2 is 17. And then x plus 4, or 15 plus 4 is 19. Yeah. Those are our 3 consecutive odd integers. Okay. How do we feel about that? You guys feel okay with that? Did you guys do integers at all last year? Consecutive, odds, evens, barely? You have heard it before though, right? Okay. The hard part is just kind of figuring out what you're gonna, how you're gonna identify your variables, right? Making sure that you pay attention to whether they're odd or even or just consecutive, and then setting up that equation. Raise your hand if you need more time with number 2. Okay, let's go to number 3. So number 3 says I have 3 consecutive even integers. So let's see, even integers like 2, 4, 6. We just said the exact same thing. That was a little creepy. How about -10, -8, -6? So every single time I have to define my integers. So I have 3 of them. So I'm going to have the first one, the second one, and the third one. So if the first one is x, what do I do to 2, my first integer, to make it equal 4? Add 2, x plus 2. What do I do to 2 to make it equal 6? X plus 4. Notice that when you have consecutive odd and consecutive even, you'd identify your variable expressions the exact same way. They're identified the exact same way because the difference between the numbers, whether they're odd or even, is an increment of 2. Okay? So now we have to come up with the expression. So it says the difference between the first and twice the second. So what does difference mean? Yeah, so I'm going to find the difference between the first integer and twice the second. The result is, that means equals 8 more than the third. What does that look like? The third integer, how do I show 8 more than that? Plus 8, yeah. So that's kind of what it's asking us. So now I'm just going to plug in those expressions. So what is my first integer? X minus 2 times, what is my second integer? It's x plus 2, right? Equals my third integer. What is my third integer? X plus 4 plus 8. So we got to do some stuff on both sides, it looks like now. It looks like we have to probably distribute on the left side and combine like terms. And then on the right side, we can just combine like terms. Yeah. So do you want to go ahead and try and distribute for us, Ariana? Okay.
I'll do like -2 times x, which gives you -2x.
Mm-hmm.
And then I would have done -2 times +2.
Which gives us 2 times 2 is,
Oh, 4.
and so it's just going to be negative. Yes, ma'am. The negatives throw you off? Yeah. So I can't combine that x with anything on the right side, but I think I can combine my 4 and my 8. 4 plus 8 is 12, yeah. Okay. So on the left side again, I think we need to combine those. What is x minus 2x? What is x?
-1.
Negative 3x. It's negative 1x.
Oh.
Negative 1x minus 4 equals x plus 12. And this x all by itself is really has a 1 in front of it. All right, so Brianna, do you want to take the negative 1x and move it over to the other side, or do you want to take the positive 1x and move it over? take the negative. So how do I cancel out a negative? 1x. What do I have to do? Add it. I'm going to add 1x to both sides. So this cancels out, and I have negative 4 equals 2x plus 12. So I have to take my constant, that 12 that's on the right side, and I have to move it over to the left side. Minus 12 on both sides. Good job. So I'm going to kind of draw a little arrow. So let's see, negative 4 and negative 12 give me negative 16 equals a positive 2x.
And then you divide positive 2x on both sides.
Yeah, just by the 2. You're just dividing by the 2.
I meant just 2.
I knew what you meant. So negative 8 equals x. So if our first integer is negative 8, what is our second integer? What is negative 8 plus 2? It's going to be getting
Negative 9.
negative 6. Yeah, it's getting closer to 0. And what is negative 8 plus 4? Negative 4. So those are your 3 consecutive integers. Negative 8, negative 6, negative 4. How do we feel about that? Scary?
I feel like this is easy. I feel the only part I would struggle on is starting at like first, like with the numbers.
Yeah.
Identifying the variables, the first, second, third. Okay. So number 4, what kind of integers do we have here? What does it say about number 4?
4 consecutive integers.
Yeah, and so remember, consecutive integers are numbers like 5, 6, 7, and 8. So let's define our variables. We have 4 of them this time. So first, second, third, and fourth. So notice that I always make the first integer what? It's like my starting point.
Oh, and
X. Yeah, I always call the first one X. So what do I do to X, or the number 5, to make it equal 6?
add 1.
Add 1. X plus 1. So that's my second integer. What do I do to the number 5 to make it equal 7? Add 2. So this is going to be X plus 2. And this is the first time we've used 4 integers. What do I do to the number 5 to make it equal 8? Good job, X plus 3. So when I am identifying my variables, and I kind of use a string of numbers just like that 5, 6, 7, 8 to help me, what do I do to get to the next one and to the next one?
But I have a question.
Yes, ma'am.
So for these 3 problems that we've done so far, you can just pick random numbers as long as they're like.
To get you started, you mean to get your brain thinking of how you're, yeah, as long as they're evens or odds when it specifies, or consecutive in a row. Yeah, just to get your brain thinking about, like, what did you do to 4 to make it get to 6? What did you do to 4 to make it get to 8? Yeah, I would absolutely do that. Okay, so it says the sum of the 4 integers. What does that mean? The sum of the 4 consecutive integers. Go ahead, Owen.
So we're adding them all up.
Yeah, it just means that we're going to add them all up. And I'm just going to write exactly what you said. Add them all up. And it says is, which means equals negative 18. So that means I have to take my first integer, which is x, plus my second integer, which is represented by what? X plus 1. Plus my third integer, which is represented by what?
X plus 2.
X plus 2. Plus my fourth integer, which is represented by, and it has to equal negative 18. So we've got some x's that we can combine, as well as some constants that we can combine. So when I group together all of my x's, Aiden, what is it when I get all my x's grouped together? How many x's do I have? 4x. Plus, when I group together all of my constants, what do I get? What's 1 plus 2 plus 3? Daniel, 6 equals negative 18. Okay. What do you want to do next, Kenna?
Minus the 6.
Yeah, minus the 6 or subtract that 6 from both sides. Good job. So 4x equals same signs, add and keep. What'd you say, Kenna?
Negative 24.
Good job. I interrupted you. I'm sorry. Negative 24. Last step. Kylie, what's the last step? It says 4x equals negative 24. How do we get x all by itself? Good job. Divide both sides by 4. So that means that x equals negative 6. X equals negative 6. Okay. So our first integer is negative 6. What is negative 6 plus 1? Negative 5. Good job. What is negative 6 plus 2? Negative 4. And what is negative 6 plus 3? So those are our integers. Okay. How do you feel about that?
Good. I think this one helped me a lot. With
Good.
getting understanding.
Okay. So let's talk about something that we said that I think is a really good point. Ariana asked the question, can you pick any string of numbers? So when we're looking at consecutive integers, and I'm just going to abbreviate that, consecutive, remember those are just numbers that come in a row. I always identify my first integer as x, and then I say to myself, what do I do to 2 to make it equal 3? I add 1, so that's my next integer. What do I do to 2 to make it equal 4? I add 2. That's my next integer. The only time that it's different is when you have evens or odds, and they actually are identified the same way, 4, 6, 8, or 3, 5, 7. Let's take a look at them. If I make my even first term in x, or even my odd first term in x, what do I do to 4 to make it equal 6? What am I adding to 4? Plus 2. So my second one is x plus 2. What am I adding to 3 to make it equal 5? It's also x plus 2. Do you see how they identify the same way? What do I do to 4 to make it equal 8? 4 plus what is 8? 4. So my next one is x plus 4. What do I do to 3 to make it equal 7? Add 4. So even though evens and odds are very different, the pattern, 2 apart, 2 apart, 2 apart, so you identify your variables the same way. So you can pick any string of numbers to help you identify your variables. Okay? Good, good.